Rocket-propelled planes have been built, designed to take a man up to very high altitudes. To overcome the effect of gravity, the rocket plane is carried to high altitude by a large transport plane. If the cruiser were launched directly from the ground, much of its fuel would be used up in pulling away from the Earth's gravity field, which is strongest at the surface of the Earth. This makes the rocket plane the same in principle as the last stage of a multi-stage rocket. Both must be well away from the surface of the Earth before they are fired.
20 seconds to launch. 15 seconds. 10 seconds. 5, 4, 3, 2, 1.
For probing deeper into space, scientists have proposed another way of overcoming the problems of fuel and gravity. They propose space platforms, or way stations in space. Like the transport plane and the first stages of a multi-stage rocket, the way stations would provide a base from which a rocket may be launched. Various forms have been suggested, but a space station might look something like this. Such a space station might be built about 1,075 miles above the surface of the Earth. If it were farther out, it would be more difficult to send supplies. If it were closer, it would revolve around the Earth too quickly. It would, however, have to move fast enough to avoid being pulled down to the Earth by gravity. The Earth's gravity still pulls the station, of course, but the direction of the pull is changed by the satellite's forward motion. Instead of falling to the surface of the Earth, it keeps falling around the Earth. Station parts may be prefabricated on Earth, then delivered into orbit by transport rockets and assembled in space. Crewmen will arrive in the same orbit and travel at the same speed to carry out construction. The sections of the space station will be nearly weightless, and one man will be able to move objects that had to be lifted by huge cranes back on Earth. The men will be nearly weightless too, and will have small propulsion units attached to their spacesuits to help them move about. On the inside, the completed station would have to have its own artificial atmosphere. There would be very little pull of gravity to hold objects and people in place. To substitute for gravity, the station may be made to spin like a giant wheel. This would create centrifugal force and would give the occupants a feeling of gravity. They would be thrust outward toward the rim of the station. This would be down to them. Up would be toward the hub of the station. The way station may also be used for a research laboratory and for testing equipment for a journey farther into space. Besides the problems of getting into space, we also have the problem of returning to the Earth from space. As a rocket approaches the Earth from space, it gathers speed. It also meets increased friction as the atmosphere becomes more dense closer to the Earth. Friction causes the rocket to become so hot that it burns up like a small meteor. Once we solve all these problems about space stations, Jane wonders why we couldn't put one on the moon. And we could. You might say that the moon is a ready-made way station in space. The moon is about 240,000 miles away, about as far as 10 trips around the Earth. To get 1,000 miles from the Earth, a rocket would need this much power. To get to the moon, a rocket would need just a little bit more. Landing on the moon will have its problems. The moon has little or no atmosphere, so friction and heat would not be a major problem. But the moon does have a gravity field, although it is not nearly as powerful as the gravity field of the Earth. A spaceship would approach the moon at high speed. Small rockets could be used to turn the base of the ship toward the moon. Other rockets would fire out of the base to slow down the spacecraft so that it could make a safe landing. The surface of the moon is quite different from that of the Earth. It is covered with large pits or craters. These may be places where large meteors collided with the moon in times past. In addition to craters, there are mountains, crevices, plains, and plateaus. During the day, which on the moon is equal to about 2 Earth weeks, the temperature goes over 200 degrees Fahrenheit. And during the long 2-week night, it goes as low as about 250 degrees below zero. To escape the extreme temperatures, the moon station would probably be underground, where the temperature remains more moderate. It would need a source of power. Green plants might be used to produce oxygen within the station. The station would have to be sealed to retain its artificial atmosphere. Probably the only parts of the station on the surface would be observation domes, entrance ports, and radio antenna. Taking off from a moon base, a space vehicle would not have to pass through a dense atmosphere. It would only have to pull away from the moon's comparatively weak gravity field. It could then head for Mars. At rocket speed, cruising through the very thin gas that appears to fill space, it would take many months to get to Mars. We would probably find some sort of atmosphere on Mars, but not an atmosphere like our own. If other planets, more like our own, exist, they are unknown planets of other suns far out in the universe. The star or sun nearest to our own is about 25 trillion miles away. It would take far more than a human lifetime to travel this distance at present rocket speeds. We have seen that one problem in reaching space is to escape from the Earth's gravity field. A great amount of energy is required to escape from this pull. Another important problem is re-entering the Earth's atmosphere at low enough speed so that friction is not too great. Too much friction causes too much heat. Man-made space stations in nearby space might go far toward overcoming the effect of gravity. Such stations would orbit the Earth like satellites and could serve as taking-off points for more distant places. The moon might also serve as a way station. A rocket with enough power to pull away from the Earth would require only slightly more energy to carry it to the moon. Small rockets can be used to turn a spacecraft while it is in flight. Braking rockets may serve to slow it down enough to make safe approaches and landings possible. The moon might serve as a taking-off point for other planets in our own solar system. A space vehicle could pull away from the moon's weak gravity field easily enough. From there, man could go on to the other planets. Mars is the one most like our own. Even so, it is doubtful that living things like those we know exist on Mars. If other planets more like our Earth exist, they must be planets of other suns that are trillions of miles away. There is so much we can learn in the universe. It is the frontier of the future. And way stations in space are the stepping stones for its exploration. Hold it. That thing will never go anywhere. You forgot one of the stages. There. Now you can launch it. Uncle Bill works with rockets. Jane, Bob, and Mike don't quite understand why rockets have to be fired in different stages. Uncle Bill explains that not all of them do, just some of the big rockets that use liquid fuels. They need a vast amount of fuel to pull away from the Earth's gravity field.
20 seconds to launch. 15 seconds. 10 seconds. 5, 4, 3, 2, 1.
To overcome the effect of gravity, the rocket plane is carried to high altitude by a large transport plane. If the cruiser were launched directly from the ground, much of its fuel would be used up in pulling away from the Earth's gravity field, which is strongest at the surface of the Earth. This makes the rocket plane the same in principle as the last stage of a multi-stage rocket. Both must be well away from the surface of the Earth before they are fired. For probing deeper into space, scientists have proposed another way of overcoming the problems of fuel and gravity. They propose space platforms, or way stations in space. Rocket-propelled planes have been built, designed to take a man up to very high altitudes.